What is Git? Git is a version control program that you can download to your computer. If you wish to work on your own project or with other developers on a coding project, you must use Git. You can execute the command git version in the terminal to see if Git is already installed on your machine. Git helps you keep track of the changes you make to your code. It is basically the history tab for your code editor with no incognito mode. If at any point while coding you hit a fatal error and don't know what's causing it, you can always revert back to the stable state. So it is very helpful for debugging. Or you can simply see what changes you made to your code over time. Git also helps you synchronize code between multiple people. So imagine you and your friend are collaborating on a project. You both are working on the same project files. Now Git takes those changes you and your friend made independently and merges them to a single master repository. So by using Git you can ensure you both are working on the most recent version of the repository. So you don't have to worry about mailing your files to each other and working with a ridiculous number of copies of the original file. Git workflow. Before we start working with Git commands, it is necessary that you understand what it represents. What is a repository? A repository, aka repo, is nothing but a collection of source code. There are 4 fundamental elements in the Git workflow: working directory, staging area, local repository, and remote repository. Git add is a command used to add a file that is in the working directory to the staging area. Git commit is a command used to add all files that are staged to the local repository. Git push is a command used to add all committed files in the local repository to the remote repository. So in the remote repository, all files and changes will be visible to anyone with access to the remote repository. Git fetch is a command used to get files from the remote repository to the local repository but not into the working directory. Git merge is a command used to get the files from the local repository into the working directory. Git pull is command used to get files from the remote repository directly into the working directory. It is equivalent to a git fetch and a git merge. Step 0. Make a GitHub account. Duh! If you don't already have one, you can make one here. Step 1. Make sure you have Git installed on your machine. If you are on a Mac, fire up the terminal and enter the following command: git version. Step 2. Tell Git who you are. Introduce yourself. Slide in. Seriously, mention your Git username and email address, since every Git commit will use this information to identify you as the author. Step 3. Generate/check your machine for existing SSH keys. Optional. Why, you ask? Using the SSH protocol, you can connect and authenticate to remote servers and services. With SSH keys, you can connect to GitHub without supplying your username or password at each visit. Step 4. Let's create a new repository on GitHub. Follow this https://github.com/new now. Locate to the folder you want to place under Git in your terminal. Initialize Git, and to place it under Git, enter $touch readme.md hash to create a readme file for the repository. $git init hash initiates an empty Git repository. Now go edit the readme.md file to provide information about the repository. Add files to the staging area for commit. Now to add the files to the Git repository for commit. $git add. Hash adds all the files in the local repository and stages them for commit. Or if you want to add a specific file, $git add readme.md hash to add a specific file before we commit. Let's see what files are staged. $git status hash lists all new or modified files to be committed. Commit changes you made to your Git repo. Now to commit files you added to your Git repo. $git commit m first commit hash the message in the is given so that the other users can read the message and see what changes you made. Uncommit changes you just made to your Git repo. Now suppose you just made some error in your code or placed an unwanted file inside the repository. You can unstage the files you just added using $git reset head 1. # remove the most recent commit. # commit again. Add a remote origin and push. Now each time you make changes in your files and save it, it won't be automatically updated on GitHub. All the changes we made in the file are updated in the local repository. Now to update the changes to the master. $git remote add origin remote _ repository _ URL. # sets the new remote. The git remote command lets you create, view, and delete connections to other repositories. $git remote v. # lists the remote connections you have to other repositories. The git remote v command lists the URLs of the remote connections you have to other repositories. $git push u origin master # pushes changes to origin. Now the git push command pushes the changes in your local repository up to the remote repository you specified as the origin. See the changes you made to your file. Once you start making changes on your files and you save them, the file won't match the last version that was committed to Git. To see the changes you just made, $git diff # to show the file's changes not yet staged. Revert back to the last committed version to the Git repo. Now you can choose to revert back to the last committed version by entering $git checkout. Or for a specific file, $git checkout, file name. View commit history. You can use the git log command to see the history of commit you made to your files. $git log. Each time you make changes that you want to be reflected on GitHub, the following are the most common flow of commands. $git add. $git status # lists all new or modified files to be committed. $git commit second commit. $git push u origin master. Now if we go and see our repo, we can identify whether the commit was successful by looking at the commit message for each file. Step 5, that's all well and good. But how do I download and work on other repositories on GitHub? Cloning a Git repo. Locate to the directory you want to clone the repo. Copy the link of the repository you want and enter the following. $git clone remote _ repository _ URL. Collaborating. So imagine you and your friend are collaborating on a project. You both are working on the same project files. Each time you make some changes and push it into the master repo, your friend has to pull the changes that you pushed into the Git repo. Meaning to make sure you're working on the latest version of the Git repo each time you start working, a git pull command is the way to go. So to make sure those changes are reflected on my local copy of the repo, $git pull origin master. Here's two more useful Git commands, $git fetch and $git merge. In the simplest terms, git fetch followed by a git merge equals a git pull. But then why do these exist? When you use git pull, Git tries to automatically do your work for you. It is context sensitive, so Git will merge any pulled commits into the branch you are currently working in. Git pull automatically merges the commits without letting you review them first. When you git fetch, Git gathers any commits from the target branch that do not exist in your current branch and stores them in your local repository. However, it does not merge them with your current branch. This is particularly useful if you need to keep your repository up to date, but are working on something that might break if you update your files. To integrate the commits into your master branch, you use git merge. And that's pretty much it for the basics. Stay tuned for part 2, which will focus on branch, merge, stash, rebase, etc. If you enjoyed the article, don't forget to smash like, subscribe and comment, and make sure you follow me for part 2.